Okay, we are skipping to 2.4. So we already talked about these key terms. Again, I recorded this in the past and knowing that we would already talked about this. So again, closing costs is on your formula sheet. Just a reminder that it's 2 to 7%. Just an extra fee you have to pay. You have your down payment, but then you also have these closing costs, these fees that you pay in order to close on your house, which means basically sign the contract and get the house. And we talked about amortization as well. We're going to look at mathematically a bit more how that works. So example one, this is just easy peasy closing costs. Leah and Josh know that they will have to bring their checkbook to the closing. Now they also have their down payment, but again, this is something different. What might they expect to pay for closing costs if the house price was $165,000? So once again, I should have already had this up. On our formula sheet, this is there just in case you forget. It's right there near the top. Closing costs range from 2 to 7% of the purchase price. So again, that just means that it can be anywhere in between those two numbers. So when it asks what might they expect to pay, they can expect to pay anywhere from 2% to 7% of the price of the house. Now, again, they would tell you ahead of time. They're not going to be like, oh, surprise, just bring your checkbook and you'll write us a check. We're not going to tell you what it is yet. They'll tell you ahead of time how much money you need to have ready, but it could range anywhere from 2% to 7%. So all you have to do literally is take 2% of 165,000, 7% of 165,000, and then those two numbers are our answers, and that's it. They could expect to pay anywhere between these two numbers. So why don't you go ahead and try it. Find 2% of 165,000, find 7% of 165,000. Go ahead and try it. Okay, so 2%, that's 0.02. Once again, guys, I need to reach a point where you understand how to get what the decimal is. 0.02, not 0.2. Be very careful. And because we are taking a percentage of, we're going to multiply. So this is the lower end of what they could expect to pay in additional fees for their house. So this is $3,300. Then the 7%, that's going to be 0.07. Once again, guys, if you do not know off the top of your head what it is, divide in your calculator, it'll show you. 0.07 times 165,000 again. We get 11, much higher. So what this means is this is the range of additional fees, additional closing costs that they could pay when they close on their house. Yes, you still have the down payment, and then you also have these additional closing costs. So it kind of sucks. It's a lot of money you have to have saved up for a house, more than you might think. Okay, so I want you to read this question. Now there is a key word here that tells us we are only going to do one of the percents. So read the question and then see if we can tell what percent we're going to use. This is still closing costs, 2 to 7, but read the question so you can tell something. So here's the key word here. What is the maximum closing cost? Well, if it ranges from 2% to 7%, that means 7% is the maximum, right? So in this question, you only need to find 7% of 340,000. Go ahead and do it real quick. Okay, so 7% of 340,000, 7% is 0.07. Once again, that's 7 divided by 100. Do it in your calculator. Times 340. 0.07 times 340. Okay, so this is the maximum they could expect to pay. Yes, even just 7%, just little 7%, can be a lot because they also still have the down payment. So when you are saving for a house, again, you might need to save for more than you think. Okay, so that's closing costs. Now we're going to talk about, again, this concept of amortization, this concept that in your one payment, part of it is going towards paying off the principal and part of it is going towards paying off the interest. Now, for this question, we're going to start off by reviewing their monthly payment formula. It says, what will be their monthly payment? And we have we have all of this information. So I want you to look back to your formula sheet. Oops. It's right here. Matrix, sorry. My dog is chewing on a roll of tape. So on your formula sheet, I want you to take a moment. We've already done this. I'll copy the formula over real quick, actually. R divided by 12. This is on your formula sheet. This is the monthly payment formula. I want you to take a moment, see if you can remember. Go into Desmos, try it on your own. Try to plug everything in. Again, a strategy is to write out what P, R, and T equal, and then write it out with everything plugged in. Go to Desmos and try and plug it in yourself. Okay, and I should have had Desmos pulled up. I'm going to have to cut this part out because I forgot we're doing this part. Okay, so P is this 300,000. P is your principal, yeah? How much your loan is. The R is 5.75. However, 5.75 divided by 100, guys, it doesn't matter, excuse me. If you have a percent symbol, you have to divide it by 100 and get it as 0.0575. If it's 0.575, or if you left it as 5.75, you're going to get an obnoxiously large answer. Make sure you still divide it by 100. And then the T is the 15. So again, I would have plugged all this in. I'm going to go ahead and still do it. It's kind of tedious here, but you can skip this part if you already plugged it all in. 0.0575 divided by 12. 1 plus 0.0575 divided by 12. Now remember here, this is 12 times 15, but I'm going to come back to that and figure out what that is ahead of time before I go and plug in my calculator. Okay, so again, this is because of the way Desmos works. So 12 times 15 is 180. So I'm going to go ahead and erase that and replace it with 180. 12 times 15 is 180. Then I would go to Desmos and I would plug this in. So let's see if we got the same answer here. Or if you haven't yet tried in Desmos, you might want to try it on your own and then we can compare. So very first button you hit is fraction button, always. Then we have the top, 1, 2, 3. Be very careful that you have the exact number of zeros, guys. That'll mess it up too. There's 5 zeros there. 300,000 parentheses. 0.0575 divided by 12. Click over. Parentheses, 1 plus 0.0575 divided by 12. Need to click over. To the 180. Once again, don't do 12 times 15, doesn't work out quite right. I have 1 plus, oops, I guess I can do that. 0.0575 divided by 12. To the 180, and then do not forget the -1. Super common mistake to forget that. So here's the monthly payment, $2491.23. So I'm gonna write that over here. 2491.23. If you did not get that, take a moment to go try it again in Desmos. If you're still making mistakes, take a picture of it and send it to me and I can help fix what you're messing up. So here's what they pay every month. Now here's the thing, once again, here's what we need to understand about this concept of amortization. This does not change. This is one of the benefits of having a house is that for 15 years in this case, for 15 years, that will be my house payment. It's guaranteed locked in. However, what does change is how much of it is going towards principal and how much of it is going towards interest. That actually changes over time. So what we're going to do is, again, this splits up into interest, and the rest is principal. This should look familiar, right? So it says how much of their first monthly payment will go to interest. This is, again, on our formula sheet. First month's interest right there. So we're going to use this formula to figure out how much of their first payment they make will go towards interest and how much will go towards principal. Finding another month in the future for how much goes towards interest and how much goes towards principal is a little confusing and not as simple as doing just the first month. That's why they will only ever ask of their first monthly payment. So again, this is the formula we're going to use right here. The interest equals the principal times R divided by 12. So let's go ahead and bring it back. I'm going to use that formula. I equals P times R over 12. This is again the formula sheet. First month's interest. So we are going to figure out how much goes towards interest. The rest goes towards principal, and you should know how to do that because we've done this breakdown very often. So let's do this right here. Let's see what their P is. Their P is 300,000 times their R is 0.0575. Excuse me. 0.0575 divided by 12. That's because this is an annual rate. It's an APR, and that's for annual. We divide by 12 to get the month. So let's plug this in the calculator. You might need to go at Desmos. 300,000, excuse me, times 0.0575 divided by 12. We get the first month payment. That's how much money is going straight into their pockets. Yeah. That's profit for them, right? They have to start making profit right away. They can't wait until you've given them at least $300,000 before they can start making a profit. So they take some of your payment for profit and then they put the rest towards your principal, right? We talked about this in class. So I'm going to go ahead and kind of skip down here. Actually, I'm going to rewrite this because here's our monthly payment, $2491.23. I have just found using that formula that this much goes towards interest. So you should know what to do. How are we going to find how much goes towards principal? What should we do? We should subtract these two, right? We're going to minus these two because here's my full payment. There goes $1,437.50. That's subtraction, right? We want to see what's left over. So let's subtract these. 2491.23 minus 1437.50. So this is how much is actually going towards paying off your loan from your first payment. So these are our two answers. That's how much goes towards their pockets. This is how much actually goes towards paying off your loan. Very important concept to understand about paying back loans. You make this whole payment, but what you owe does not decrease by that much. So let's try this again. Again, what you're going to do, let's review what we did. You're going to find their monthly payment doing that formula that we know. Then you're going to break it down into interest and principal. We have this formula for interest. We figure out the rest that is the principal. So go ahead. I want you to try this again. Start off by finding his monthly payment here, and then we'll come back and check. Okay, so I know I have this formula memorized, but I'm going to go ahead and write it all out. This is T. This is 0.045 is R. So this is what it should have looked like plug in. I don't recommend skipping all the way to here. It's just because I have this all memorized. So you can check and make sure if yours matches. This is exactly what you should have plugged into the calculator. 12 times 30, we'll come back to that. 1 plus 0.045 divided by 12. 12 times 30 minus 1. And I do know that 12 times 30 is 360, so I'm going to go ahead and replace that here. Okay, let's head over to Desmos and plug this in. We got fraction button, very first button you hit. We need the top and the bottom. 150,000, right? Yes, 30. Come back up here. Parentheses, 0.045 divided by 12. You need to click over, close parentheses, 1 plus dang it again. 0.045 divided by 12 to the 360 plus 12 times 30. Then I have 1 plus 0.045 divided by 12 to the 360. Do not forget the minus 1, super common mistake. Okay, so 760.03 is what that should round to. So make sure this is what you got for your monthly payment. If you did not get that, you need to go back and try it again because we need to be consistent with these because you've only got one shot on the test to get it right. And if you can't plug this in consistently, then there's a good chance you're going to get it wrong on the test. Okay, so here's the monthly payment, 760.03. Some of it goes into their pockets as interest. Some of it goes towards principal. Look back and see what we did for interest. We're using that first month's interest formula. So take a moment, look back to your formula sheet, or look back to the last question. Go ahead and calculate the interest using that first month's interest formula. Okay, so we have that I equals P times R over 12. P is the 150,000. R is the 0.045. So we've got 150,000 times 0.045 divided by 12. So here's how much is going towards interest. 562.50. Now, just a little hint, guys. Again, that's the I. Just a little hint. If you have your monthly payment and the first month's interest comes out to be greater than the monthly payment, that means you plugged into this formula wrong and you have the wrong answer for your monthly payment. This interest cannot be higher than how much money they're giving the bank, right? So just keep an eye out for that. If you do this problem and you see a higher interest than the monthly payment's wrong. So all we need to know then is what's left over. So we are going to subtract these two. So for our P, we have 760.3 minus 562.50. So this is how much is actually going towards paying off your loan. And you should get 197.80. Yes, in the beginning, that's principal. In the beginning. Most of your payment is going towards interest because in the beginning, they want to get as much money out of you as possible. So more of your payment goes towards interest in the beginning. As time goes on, and again, we looked at this in class, the balance changes. This doesn't change. That's the cool thing. 760.3 doesn't change. But the balance of how much of it is interest and how much of it is principal changes over time. So when you are almost done paying off the loan, and this is the case for cars as well, just an FYI, most of your payment goes towards principal at the end. Most of your payment goes towards interest in the beginning. They want to get as much money as possible in the beginning. So this is hopefully not terribly confusing. Hopefully you can follow along with this as you're doing your homework. I know the concept itself is a little weird, but hopefully you guys can follow along with the math. Please reach out to me if you're a little bit confused though.